Hello all. So in last video, we have seen our naive Bayes algorithm, but in just theoretical manner. So let's try to just revisit one of the most important things and then take a thorough example of it. So over here, I already showed you that how it works, but some of you ask me that why this conditional independence? Can you explain a bit more about this conditional independence, that how this feature xi is not dependent on any other features? Right? So we can directly write xi given ck, and we are assuming the naive conditional independence. So how it's possible in real life? So let me cook up an example that, for example, let's say we are predicting a mobile phone like dislike predictor. Okay, that is whether a customer will like mobile phone or not. So let's say we have features like screen size or battery capacity or battery power, right? And then let's say we have the price and so on. Let's say we have three features and our output is y, whether we will like a phone or not, don't like phone. For example, let's say for any feature xi, let's say the screen size is 6 inches, battery power is 3000 mAh, and price is, let's say, 10k, right? US dollars or any other currency if you like. But let's say we have a data set like this. So is it, let's say our xi is some feature battery power. So is it possible to have, let's say xi is now 2500 mAh? So what is the probability of getting 2500 mAh in a data set given other features? Like let's say screen size is 5 inches and also the price is 5k, right? And given it will belong to class 1, that is the customer will like it, right? Will like the phone. 1 means like the phone. So it's really hard to find such a point in the data set which exactly satisfies such a criteria, right? Because in future we might get some other values like 3000 or 3100 or anything, given the screen size can be 6.5, 5.5, anything, right? And also the price can be. So it's really hard to find an exact data point which satisfies this feature dependence at the same time. And that's why we just try to assume this conditional independence, which is really naive. That's why we call it naive Bayes. So that, I hope that will make some things more clear in terms of why it's called naive Bayes. Now let's move to a thorough example. So we will see this advantages and disadvantages and some characteristics as we proceed. But let's try to take an example. It's a toy data set or toy example just to understand. But these are all the things which we already discussed in our last videos. I'm not going to repeat that. But the example is that we have to find whether the player plays or not, right? Based on the outlook, whether it's rainy, sunny, overcast, and so on. So we have, I guess, rainy, sunny, and overcast as three possible outlooks. And we have to decide whether a player will play or not. So what we have to do? Simply, just we have to calculate the probabilities, right? So what will be our requirement? Our goal is to find the probability of playing given it's sunny or given it's rainy or given its outlook, right? For any new data point. So that's what we have to find. And we are given the data set for, I think, 14 days from 0 to 13. So what we can do? We know our Bayes theorem. This is Bayes theorem. This might be a mistake a bit. So this is A given B is given by B given A into probability of A and divide by probability of B. So what we have to find? We have to find the probability of sunny given, probability of finding yes, you can play given it's sunny. So it will be the other way around using the Bayes theorem, that is sunny given yes into probability of playing yes and then probability of sunny, right? So it's really simple. We can calculate directly from the table all the probabilities. So let's try step by step. That what is the probability that it's sunny and it's yes. So we have to just here see where it's sunny and where it's yes. Okay, so let me just highlight that for you. So first, then sunny and yes second, and sunny and yes, it's here. 3, right? So we have just 3 possibilities. And thus what we will do, we can just directly write 3 by 10, which is 0.3. So what probability of sunny and it's yes, together given it's yes, it's just 3 by 10, or we can say 0.3. Similarly, what's the probability of yes? So here out of 14, if you will calculate, we have 10 times yes. So we'll just write 10 by 14, which is 0.71. And what is the probability of sunny? How we can calculate that? So it's simply 5 by 14, because we have to see how many times it's sunny. So it's 1, 2, 3, 4, and 5, correct? So we are getting 5 by 14. And thus, just we are simply putting in this formula and we'll get 0.60. But this is for probability of yes. Similarly, we can proceed for probability of no, that you can directly see, and we are getting 0.4. So obviously the yes is 0.6 and the no is 0.4. So yes is greater. So we'll say that we'll play. So for any other new data point, let's say it's rainy or overcast or anything about this outlook. So outlook is here is a categorical variable. It takes just 3 unique values, whether it's rainy, sunny, and overcast. Okay, so that's how it goes. It's really simple. That's why what we are doing, we are just simply calculating the frequencies, right? That how many times such something is happening, right, from our data set, and we are simply getting this. But these are for categorical variables. What about, this is the example of text classification. That is, we are given a sentences and we have to classify whether our review, right, this is a food review, is positive or not. So in that case, what we can do? So we'll discuss that thoroughly, that what we can do in terms of text based data, what we can do in terms of, so here it was categorical, right? But what if we have the continuous data set, like float values, not categorical? Then what we can do in that case? So we'll see, or at that time Gaussian naive bias will come into play, and why it's called Gaussian naive bias, we'll see that thoroughly. But let's go step by step. So now you might ask, like, this is really simple example, what about we have more than one features? So that's also really simple. Let me just try to show you that what we can do when we have more than one features, and it's really simple. So for that, I'll go to this blog. Okay, I found this by searching on Google only. So I'll put the blog's description link, okay, in the blog link in the description. So don't worry about that. So here as well, it's again explaining all this independence and stuff, like what are those terminology that we are already discussed, right? And then here it's the same example, but with more number of features. So that's why, like, I thought firstly to show you in now my Blackboard, but I thought it's better if I find some blog, and I found this. So this is the blog from Chatterline.com, and again, what we are doing, simply we are just building the tables, right? We didn't build the table in last blog, but yeah, it's like we were just seeing and calculating. But it's good to, when we have more number of features, it's good to build a table. So firstly, in the learning phase, like when the uh, it's learning, or we have to learn the model, right, based on this data set which is being given. So again, we'll just see that outlook has 3 possible values. All are categorical variables here. Temperature also takes 3 possible values: hot, mild, and cold. Similarly, humidity, high and normal, and windy, weak and strong. And based on all these features, we have to decide this. So what we will do in the learning phase, again, what we will do, simply we'll calculate this thing. We compute the table of likelihoods, right, from the training data set. That is, what is the probability of outlook O given classes, right? And for all the features, like we'll do for outlook, for temperature, for humidity, and for wind. Okay, so we'll calculate this, and we'll calculate for both the possibilities, that is for yes and no, and also for all the possibilities, that is rainy, sunny, overcast. Similarly for hot, mild, cool, high and normal, and weak and strong, for all the features. And so here we have to do a bit of work, but it's really simple. It's again like calculating how many times something occurs and just divide by total number of time it occurs. It's just a simple probability. So it's like we are calculating the frequency of occurrence. That's why it's called frequency tables as well, that we just build a frequency table. So what we do here is, outlook, we have 3 possible. That's why here we have to build a table. Over there it was just one feature, so it was easy just by seeing and calculating. But here it's good to build a feature, probability or frequency table like this. So we are first building for outlook. That is, what is the probability of outlook? It's sunny and we can play, so it's 2 times. And how, now how about like we can't play, it's 3 times. Okay, Similarly, for overcast is 4 times. You can simply just see from here, right? So total, when it's sunny, when the outlook is sunny, overcast and rain, we can play its total 9 times. Similarly, we can't play its total 5 times. So what's the probability? Just 2 by 9. So here all are just the probabilities. 3 by 5, because here it's total 5, and so on. Correct? So this is for the outlook. Similarly, we go for temperature for all the 3 possible categorical values, and we just calculate the probability, that what is the probability that temperature is hot and we can play. Correct? And divide by total, that this is total should be how many times we can play, because we have to find the likelihood, and likelihood is like this thing, that class is whether it's yes or no. Here B belongs to yes and no. And why likelihood? I'll just recap. This is called likelihood, that is X given class, that is feature given class we have to find, right? So what is the feature, which is our outlook, temperature, humidity and wind, given the class, that is either yes or no. Correct? So this is how we go. And also at the end, we also have to find the priors, right? Which are called the priors. This one, what's the probability of class, and which is really simple, right? That how many times it's yes and how many times it's no. So we know that 9 times is yes and 5 times is no. So these are prior probabilities, which are really easy, right? Now in the classification phase, what we can do, we also obviously we use the map rule, which is maximum a posteriori probability. So let's say we get a new instance and we have to classify whether we can play or not in that weather condition. So let's say outlook is sunny, temperature is cool, humidity is high, and wind is strong. Okay, then we have to see that how it will be classified. That is, we are going to play tennis or we are not going to play under this new condition. So simply what we will do, what we are given, we have to classify whether we can. This is the posterior probability, that whether we can play given a new feature, right? So simply it will be the other way around, right? Using the Bayes theorem formula or the conditional naive Bayes class conditional independence that we derived. So what we have to do, we have to simply just find the other way around. First, it's sunny. So sunny given we can play. Similarly, it's cool. Then cool we can play. Yes. Then high we can play, and then it's wind and we can play. Wind is strong and we can play. And into probability of priors. So what we did is just simple, that what is given we can play here given the class, right, and so on. So this is how we do, and at the end the class probabilities. So that's what it's done here, and simply we know all the probability values from this tables, that is 2 by 9, right, when it's sunny and we can play. So here we know that when it's sunny and we can play, it's 2 by 9. So all the values we know from the tables, so we can simply calculate this. Similarly, we can calculate for no, and with the map rule, which is maximum a posteriori probability, we know that we have to just compare which probability is greater. So this is greater than this value, so that's why we'll decide that we cannot play in the given weather condition. So given any new instance of the weather conditions, right, all the 4 features, we can simply derive whether we can play or not. So in next video, this was a toy example that how simple this algorithm is. So we don't have to do anything, right? Just calculate the frequency tables and we are good to go. But in next class, what we will do is take a real life data set and try to code everything in Python. And then we will also see thoroughly that what we can do in terms of continuous variable or continuous features, right? So that, as I said, the Gaussian naive Bayes comes into play. So we'll see how Gaussian works and so on. So I'll end this video here, and thanks a lot.